Mr. Lucier's Chemistry!
Hello everybody, welcome back to chemistry. We're still talking about acids and bases, and last time we talked about acids and pH. Today we're going to talk about bases and pH. Before we get started, we're going to do a quick recap. Remember the pH scale. From below 7 all the way to 0, we call those acids, or it's acidic. And then above 7, anything above 7, and those are basic or alkaline. And if it's exactly 7, we call that guy neutral. So that's the pH scale. And we also talked about concentration last time. Remember, concentrations, we look at the moles of what's dissolved in the water, the total volume of the water, and it's given to us in the big M molarity. And we also said if we see anything in brackets, that also represents concentration. Okay, anything in brackets represents concentration. Well, we talked about acids last time. And the two formulas they gave us, well, if they wanted us to calculate pH, it was minus log of the H plus concentration or hydronium concentration, and that gave us the pH. And on the flip side, if we had the pH and they wanted us to calculate concentration, it was 10 to the negative pH, and that gave us our H plus concentration. So we had two ways of calculating. We could calculate pH of an acid, or we could calculate the concentration of an acid. Either way, it was a pretty simple calculation. Today we're going to talk about bases. For bases, we're actually looking at the hydronium concentration in a solution, the amount of OH in solution. So we're looking over here on this basic side of the pH scale. Now, if we want to calculate using the same method, because it's the same calculation, if you take the negative log of the hydronium ion, that does not give you pH. What it's going to give you is this thing called pOH. So we're looking at pOH now, because when you take the negative log of a concentration, if it's of an acid, H+, it gives you pH. But since we're doing the base, the OH, it's going to give me pOH. Nice and simple. So let me give you an example here. If I have a concentration of, let's say, I don't know, 2.3 times 10 to the negative 7 molar solution of NaOH, and I want to know what the pH is, question mark, right? I want to know what the pH is. Well, all I got to do is plug my concentration into this calculation. So let's go ahead and do that real quick. Pull out my calculator, turn it on, clear it out. So if I take the negative, I'm going to hit the negative button, negative log, I'm going to enter in this concentration, 2.3. I'm going to use the second button and that button above 7, the EE. So when I hit the second button and that button above 7, your calculator might be different. But what you're looking for is that EE button, and it puts that E. That E means times 10, so you don't have to hit times 10. So all I got to do is just hit the exponent. So right here, I don't need to type that because that is equal to E. So all I need is the negative 7, so I type in negative 7, close my parentheses, and hit equal. So what this does is you see the answer is 6.6. So that means my pH, well, see, even I'm getting it wrong. It's not pH I'm calculating. What am I calculating here? I'm calculating pOH. See how easy it is to get this wrong? pOH is equal to 6.6. Okay? So you got to remember, if you're working with a base, anything that has this hydroxide in it, when you do the calculation, you're getting pOH, not pH. That is a huge, huge deal, and it's going to become more important later. So now I have a pOH of 6.6. What does 6.6 tell me on the pH scale? Look at it. What does it tell me? We know this is a base. 6.6, here's 6. That falls under what category? Oh no, it's falling under the acid category. No, it's not, because we cannot compare pOH to the pH scale. We have pOH. This is pH scale. So the pH scale will not work for pOH. We'll talk about the conversion later, but for today we're just going to work on calculating pOHs. Okay? But just know, you cannot use pOH to use on the pH scale. It won't work. So now we have our pOH. Let's say they gave us a pOH. Let's say we have a pOH of 4.3 pOH. And they want to know what's the concentration of sodium hydroxide. Question mark. Just doing these quick little questions. So now they've given us a pOH and they want to know what is the concentration of the sodium hydroxide. So if we want to calculate concentration, how do we calculate concentration? Remember, concentration. Right here, we got to go 10. For acids, we went 10 to the negative pH. So what do you think you're going to do with bases? Well, with bases, you're going to go 10 to the negative pOH. We're going to reverse the process, okay? And that will give me our hydroxide concentration. So now we have both our formulas here real quick. Let me square them all. So if you need to pause the video, take notes. Remember, we're only dealing with bases today. So if I want to reverse the process and they give me the pOH, I keep messing it up, they give me the pOH, then from the pOH I can get the concentration of the base. So let's go ahead and do this concentration real fast. Clear this out. So our pOH is 4.3. Let me put this up so you can see it. I went 10 up caret, open parentheses. So you see I got that 10 to the power of whatever. So now I got to enter in the negative pOH. So I'm going to hit the negative button, and what was my pOH they gave me? They gave me 4.3. So I'm going to enter in 4.3, close the parentheses, and hit equal. And now I got my concentration, 0.00005 molar solution. So I'm going to write this down. My concentration, I'm going to put OH concentration is equal to 0.00005 molar solution of NaOH. Okay, there you go. Now, that's a lot of zeros there. So your calculators, depending on your specific calculator, might give you this long answer, or it might put this guy in scientific notation. So we're going to move the decimal, let's see, past the first real number, so it's 1, 2, 3, 4, 5. So your calculator might give you 5.0 times 10 to the negative 5 molar solution of NaOH. So both these answers are correct, whether it's the long form or the scientific notation form. Don't forget, guys, when you're dealing with scientific notation, let me go ahead and write this out. When you're dealing with scientific notation, if your number is negative, that means you're going to move the decimal 5 times to the left. That's if you have whatever times 10 to the negative 5. You're going to move your decimal 5 times to the left, and that will give you the long number. Now, to put it into scientific notation, you'll just count 1, 2, 3, 4, 5 into the first real number and times 10. And then if you start off with a small number, then you'll have a negative exponent. If you have a big number, let's say I have 5 like this right here, that's a big number. So when I put it in scientific notation, 1, 2, 3, 4, 5, this will be 5.0 times 10 to the 5th power. So you got to keep track of this exponent, because a positive exponent means it's a big number. A negative exponent means it's a small number. So in this case, it would be, if we had 5.0, that would be 0.1234 right there. So that's the difference between the two. So a negative number means you come in from a small number. A positive exponent number means you're coming from a big number. Okay? So these two are the same. Okay? These two are the same, and these two are the same. So you just got to remember how to take stuff in and out as scientific notation. Because based on how you're doing your concentrations on pOH, your calculator might give you the long form or it might give you the scientific. But depending on my answers on the quizzes and tests, depending on what my calculator gave me, that's what I'm going to put as answer choices. So you might have to take your answer and put it in scientific notation or take it out. Just be aware of that. So guys, this is bases and pH. As you see, when you do the calculations with bases, it does not give you pH, it gives you pOH. Okay? And remember, you cannot use pOH on the pH scale. It's its own separate thing. So guys, this is pH and bases. I hope this helps. Have a great day.
Job's done.